Astronomers recently found a planet system that should not exist. Not because it orbits two suns, but because one of these worlds may be orbiting in a way that should have torn the entire system apart. We're talking about planets surviving in gravitational chaos. Double star systems where the sky would look like science fiction, and one discovery so bizarre it forced astronomers to rethink how planets can even form in the first place. Because for a long time, the idea of a Tatooine planet sounded wild enough. A world with two sunsets, two suns in the sky, a planet caught in the pull of two stars. Cool, right? But that's not the weird part anymore. The weird part is that astronomers are now finding planets in these systems that orbit at angles that make almost no sense, in places where the gravity should have destroyed them before they ever had a chance to survive. And one of them may be one of the strangest planets ever discovered. So what exactly did astronomers find? And how can a planet survive in a system that looks this unstable?
In the ever-expanding catalog of the cosmos, the Tatooine planet, a world orbiting two suns, has long been the gold standard for celestial wonder. But as 2026 unfolds, astronomers have moved past the mere novelty of double sunsets. A series of recent discoveries, specifically the identification of the system TOI 2267 and the perpendicular planet 2M1510 AB, B, has revealed a reality far stranger than science fiction. While the existence of circumbinary planets, planets orbiting two stars, is now well documented, the weird part isn't the two suns. It's the impossible geometry and the survival of these worlds in environments that should, by all laws of physics, have ripped them apart. The perpendicular predator, 2M1510 AB-B. In April 2025, an international team led by the University of Birmingham announced the discovery of 2M1510 AB-B. Most planetary systems, including our own, are coplanar, meaning everything sits on a relatively flat disk, like a vinyl record. However, 2M1510 AB-B is a polar planet. It orbits its twin host stars at a 90-degree angle. Imagine the two stars spinning around each other on a horizontal tabletop. The planet doesn't orbit around the edge of the table, but loops directly over the top and under the bottom. Why this is the weird part. Formation paradox. Planets are born from a disk of dust and gas surrounding young stars. For a planet to end up in a perpendicular orbit, the entire protoplanetary disk would have to have been tilted 90 degrees by a passing star or a massive gravitational disturbance during its infancy. The three-body choreography, maintaining a stable orbit in a binary system, is difficult enough. In a polar orbit, the gravitational tugs from the two central stars create a complex oscillation. Astronomers call this a delicate celestial dance, because even a slight miscalculation in speed or distance would send the planet careening into deep space or spiraling into the stellar fire. The broken records of TOI 2267. If perpendicular orbits weren't enough, the discovery of the TOI 2267 system in late 2025 added another layer of bizarre physics. This system hosts three Earth-sized planets, but its configuration defies traditional models of planetary stability. The weird part of TOI 2267. Planetary shared custody. In most binary systems, planets either orbit one star or both. In TOI 2267, two planets transit around one star, while the third planet transits its companion star. This is the first time astronomers have observed planets crossing both components of a binary pair in such a compact arrangement. The cold compactness. The stars are incredibly close and relatively cool, M-dwarfs. According to current theories, the massive gravitational paddles created by two stars orbiting so tightly should have prevented rocky, Earth-sized planets from ever clumping together. Yet, there they are, three rocky worlds thriving in a gravitational no-man's land. Bebop. 1C, the mass monster. Adding to the 2026 highlight reel is Bebop 1C, also known as TOI 1338c. While its sibling, TOI 1338b, was discovered by a high school intern in 2020, the second planet in the system was only recently confirmed using the wobble method, radial velocity. The weird part: multi-planetary rarity. Out of nearly 6,000 known exoplanets, only a handful exist in multi-planet circumbinary systems. Bebop 1C is a gas giant 65 times the mass of Earth, sitting far outside its sibling's orbit. The Victoria Sponge density. The inner planet, TOI 1338b, has a density so low it has been compared to a Victoria sponge cake. This suggests a bloated, gassy atmosphere that is currently being scrutinized by the James Webb Space Telescope, JWST, to see if it's leaking into space due to the intense radiation from its two suns. Why these discoveries matter? These weird planets are essentially the extreme athletes of the universe. They exist in high-stress, high-chaos environments that test the limits of general relativity and planetary formation theories. By studying 2M1510 AB, B's perpendicular path, or TOI 2267 shared orbits, scientists are realizing that our solar system's flat and orderly layout might actually be the exception, not the rule. The weirdness discovered in 2025 and 2026 suggests that the universe is far more creative with its orbital mechanics than we ever imagined. As the Gemini Planet Imager, GPI, moves to its new home in Hawaii this year, astronomers expect to find even more of these impossible worlds hiding in the glare of their twin suns. Beyond the orbital mechanics, the weirdest part of these circumbinary systems lies in their atmospheric survival. In a single-star system like ours, a planet receives a relatively steady stream of radiation. In a twin-sun system, however, the planet is subjected to a rhythmic roasting. As the two stars orbit one another, the distance between the stars and the planet fluctuates rapidly, creating violent, periodic spikes in ultraviolet and X-ray radiation. For a world like Bebop 1C, this means the atmosphere is never in equilibrium. Scientists using the James Webb Space Telescope have observed that these planets experience thermal tides, massive atmospheric swells that move in sync with the binary star's rotation. On a planet orbiting two suns, the weather isn't just a matter of high and low pressure. It is a chaotic response to a shifting gravitational and thermal tug-of-war. The atmosphere is literally being stretched and compressed every few days, leading to supersonic winds that dwarf the strongest hurricanes on Earth. Furthermore, the discovery of TOI 2267 has forced a re-evaluation of the habitable zone. Traditionally, we look for a Goldilocks region where liquid water can exist. In a binary system, this zone is not a simple ring. It's a shifting, complex geometry that expands and contracts. A planet could be perfectly habitable for part of its year and then plunged into a scorching inferno or a glacial freeze a few months later as the stars move into alignment. This suggests that if life exists on these Tetun worlds, it must be incredibly resilient, perhaps surviving in deep underground oceans or through extremophilic biological cycles that allow for long periods of dormancy. Finally, there is the spectacular visual reality that defies our intuition. On a perpendicular planet like 2M1510 AB, the stars wouldn't just move across the sky from east to west. Because of the 90-degree orbital tilt, the suns would appear to perform a giant, looping figure eight over the horizon. During certain seasons, one sun might never set, while the other performs a rapid dance of eclipses. The shadows on the ground would constantly split, merge, and rotate in directions that would be nauseating to a human observer. These systems prove that the universe isn't just stranger than we imagine, but likely stranger than we can imagine, existing as a testament to the chaotic, beautiful versatility of gravitational physics. Ultimately, these double-sun systems serve as the universe's most extreme gravitational laboratories. They challenge our fundamental understanding of how planets take root in chaos. As we peer deeper into the light of these twin stars, we aren't just finding new worlds. We are rewriting the rulebook of planetary existence itself.
Thanks for watching. If you enjoyed this journey through the cosmos, hit like, subscribe, and tap the bell. And when you're ready for your next space mystery, click the video right here.